Lesson 1.7 is on absolute value equations and inequalities, but we are just going to focus on the absolute value equations. Alright, absolute value is the distance a number is away from zero, and absolute value quantity is non-negative. Alright, so the absolute value of 5 and the absolute value of -5, what do those equal? Well, ask yourself, to find the absolute value of 5, how far away from 0 is 5? And you would say it's 5 units. So the absolute value of 5 is 5. Now the absolute value of -5, how far away from -5 is 0? Well, that is also 5 units. So the absolute value of -5 is also 5. So since opposites, so 5 and -5, for instance, in this example, have the same absolute value, an absolute value equation can have two solutions. Alright, so steps for solving an absolute value equation. The first is to isolate the absolute value. Alright, and then the second step is to drop the absolute value bars and rewrite as two equations. First equation is exactly what you see, and that's after you drop the absolute value bars. Alright, so drop the absolute value bars and write exactly what you see for your first equation. The second equation, what you're going to do is multiply the right hand side by -1. Alright, so those are the first two steps. The next two steps, solve both equations then for the variable, and then check for extraneous solutions. Now, what's an extraneous solution? It is a solution that does not make the original equation true, but it's not as simple as that. What I want you to add is, so an extraneous solution is derived from the, we'll go down here with it, original equation. Okay, so let's be a little bit more precise. An extraneous solution is derived from the original equation, but does not make the original equation true. So sorry, I kind of I cut some stuff out and then added some stuff in, but that should read, an extraneous solution is derived from the original equation but does not make the original equation true. Alright, let's do an example. So what's the solution to this absolute value equation? And we're not going to worry about graphing it. Well, you know what? We will. It's not that hard. Alright, so the first thing to solve these absolute values is to isolate the absolute value. And it is here already. Alright, it's alone by itself on one side of the equal sign. Alright, now the next step is to write your two equations. Alright, so the first equation, you get rid of these absolute value bars, and write what you see. So 2x minus 1 equals 5. Okay? Alright, now for the second one, you do the same thing. You drop the absolute value bars, you write the left-hand side, but the right-hand side you multiply by -1. So you're going to be left with 2x minus 1 equals -5. Alright, now go ahead and solve for both equations. Let's do the first one. Let's add 1 to both sides. So we have 2x equaling 6. Divide both sides by 2. So x equals 3. For the second equation, we're going to add 1 to both sides. So we have 2x equaling -5 plus 1, that's going to be -4. Alright, divide both sides by 2. So x equals -2. Alright, now we got to check for extraneous solutions, so we're going to plug those, plug them back in to the original and see if we get the left hand side equaling the right hand side. So the absolute value of 2 times 3 minus 1, does that equal 5? Well, 2 times 3, that gives us 6 minus 1. 6 minus 1 is 5. So does the absolute value of 5 equal 5? Yes. So this is a solution. Alright, and then let's do the other one. So the absolute value of 2 times -2 minus 1, does that equal 5? Well, 2 times -2 is -4 minus 1. So we have the absolute value of -5. Does that equal 5? Well, what's the absolute value of -5? That's 5. 5 equals 5. We're good here. That also is a solution. Now to graph, all you have to do is draw a number line, mark it up, -3, -2, -1, 0, 2, and 3. And our solutions were -2, so we draw a closed circle on -2, and 3. So we draw a closed circle on 3. And we're done with the first one. Alright, next problem. Same thing. Follow your steps. First step, isolate the absolute value. It is. Alright, so go to the second step, drop the absolute value bars, and you're going to write two equations. The first equation is what you see here. 3x plus 2 equals 4. The second equation is what you see on the left hand side, but the right hand side gets multiplied by -1. And then go ahead and solve. So we're going to subtract 2 from both sides. Alright, divide by 3. So x equals 2/3. We have 3x, oops, we're going to subtract 2, sorry. So -2, we're going to subtract 2. This right here, it's -4 now. So -2 minus 2, or -4 minus 2, that's going to give us -6. That cancels. Divide by 3. So x equals -2. Alright, let's check these. Alright, so we have 3 we have x equals 2/3, x equals -2. So we're going to plug each of these into the original equation. So 3 times 2/3 plus 2 equals 4. And the absolute value of 3 times -2 plus 2 equals 4. So 3 times 2/3, that's going to give you 2 plus 2. So the absolute value of 2 plus 2 is 4. The absolute value of 4, does that equal 4? Yes. And then here we have -6 plus 2, that's -4. The absolute value of -4 is 4. So that's good. So we know those are solutions. Alright, the next one, a little bit trickier because the absolute value is not isolated. So, what do we have to do? Get it isolated. Get this by itself, right here. Alright, so what are we going to do? Remember, when you're solving equations, you want to use your order of operations, but in reverse. So that means look to add and subtract to move things from one side of the equal sign to the other first before you multiply and divide. So that's what we're going to do here. We're not going to divide by 3 first. We're going to add 1 to both sides first. So 3 times the absolute value of x plus 2, that cancels, equals 9. Now we can go ahead and divide by 3. That cancels, so we have the absolute value of x plus 2 equaling 9 divided by 3, which is 3. Alright, let's rewrite this so we have more room. Alright, so now once the absolute value is isolated like it is here, write 2 equations. The first is drop the absolute value bars, so get rid of those and write what you see. So you would see x plus 2 equaling 3. And then for the second one, drop the absolute value bars and multiply the right hand side by -1. Solve for x for both, so we're going to subtract 2 from both sides. So x equals 1. And then we have x plus 2 equaling -3. We're going to subtract 2 from both sides. So x equals -5. Now, check for extraneous solutions. We can plug it back in here. So 1 plus 2, the absolute value of 1 plus 2, does that equal 3? Does the absolute value of 3 equal 3? Yes. The absolute value of -5 plus 2, does that equal 3? Well, the absolute value of -3, that is 3, so we're good here. And if we wanted to graph these solutions, we would just draw your number line. Alright, and we had 1 and -5, -5, -4, dot on 1, and a dot on -5. Okay, I want you to do this problem right here on your own, and I'm going to ask for answers to that problem in class. What I want to do right now is I want to add a problem. Alright, so find some space Alright, and let's write this down. The absolute value of 3x plus 2 equaling 4x plus 5. Alright, so let's just make this example 3. Alright, so the absolute value is isolated, so we can skip to step 2 and write our two equations. So we're going to drop the absolute value bars and write what you see for the first equation. And then the second equation, write what you see on the left hand side. And then you're going to multiply the entire right hand side by a negative 1. Alright, I'll go ahead and solve. So we have variables on both sides of the equal sign, so I'm going to subtract the smaller one from the bigger. So 2 equals 4x minus 3x is x plus 5. I'm now going to subtract 5 from both sides. So negative 3 equals x. Now here we have 3x plus 2 equals, now you're going to have to distribute this negative. So negative 4x minus 5. Alright, the negative 4x is smaller, so that's what I'm going to move. So I'm going to add 4x to both sides. So I get 7x plus 2 equals negative 5. I'm going to subtract 2. So 7x equals negative 7. Divide by 7. X equals negative 1. Alright, now check for extraneous. So let's see if these are solutions. So we have x equals negative 3 and x equals negative 1. Alright, so let's rewrite on another page. Alright, so the absolute value of 3 times negative 3, I'm plugging back into the original. Okay, so negative 3 times negative 3 is negative 9 plus 2. Does that equal 4 times negative 3? That's a negative 12 plus 5. So negative 9 plus 2, that's a negative 7. So the absolute value of negative 7, does that equal negative 12 plus 5? That's a negative 7. Well, the absolute value of negative 7 is 7. So does 7 equal negative 7? No. So x equals negative 3 is extraneous. Alright, that would be an extraneous solution there. Alright, so now if you plug in negative 1 back into the equation, that'll work. Alright, we're not going to do that. We've had plenty of practice doing that. Keep the video under 20 minutes. So x equals negative 1 is your only solution for this problem. Alright, and that wraps up 1.6.